Let's now talk about sinusoidal functions. In sinusoidal functions, we'll talk about the sine function and the cosine function. The general form of the sine function is f of x equals a times sine times b of x plus d. And this is the shape of the sine function. It has this shape. Also, the general form of the cosine function is f of x is equal to a sine b of x, sorry, it's a cosine, a times cosine b of x plus d. For sinusoidal functions, there are three important things that we have to know. The first thing that we have to know is the equation of the principal axis. The equation of the principal axis is simply the axis by which the function is rotating around. So in this case, the principal axis here in our curve, this is the principal axis. The equation of this principal axis is y equal to 0. This is the principal axis. Always the equation of the principal axis for any function, I take the plus d to be the equation of the principal axis. So y equals plus d. So the equation of the principal axis, y is always equal to the constant. The principal axis is the axis by which the curve is rotating around. The second thing that I need to know is the amplitude. The amplitude. The amplitude is simply the distance from the principal axis to the maximum point on the curve. This is my amplitude. The amplitude is always equal to the a value. So the amplitude is always equal to a, which is the coefficient of sine bx. The third thing that we have to know is the period of the function. The period of the function is how long the function takes to complete a one full rotation. So in our case, I can find that this function completes one full rotation from this point to this point in x. So here is the period equal to be 360. From 0 to 360, the function completes one full rotation. This is the time needed, or the x value needed, for the function to complete one full rotation, because the function starts at 0, it goes up and down, and it goes down and up again, returning to the 0 again. So the x value needed for the function to complete one full rotation, I call it the period of the function. So now, the period of the function is always equal to, the 360 degrees divided by b. b is the coefficient of x inside. So now we know the equation of the principal axis, the amplitude which is equal to a, and the period which is equal to 360 degrees divided by b. This is all what we need to know about sinusoidal functions. Let's have an example. A sinusoidal function is given by the equation y equals 20 sine 4x. Now, I know that before starting to solve, I know that the value of a is equal to 20, this is a, and b is equal to 4, and I have plus 0 outside, which is equal to what? To d. For part A, we need to sketch the graph of y equals f of x from x0 to 180. So let's draw our axis first. I want it from 0 to 180, so let's have another axis in here, like this. This line, yeah, this works. Now, I need to use my graphical display calculator to see the shape of the curve. I go exit, I go to menu, and I go to graph. In graph, I just clear this value, delete, and I enter 20 times sine 4x. I just execute. I need to fix the v window for x. It's from 0 to 180. And I draw. So I have, this is the shape of my function. If I want to see it larger, I can fix the y minimum and the y maximum, having the y minimum to be minus 30 and the y max to be 30. And then I exit and I draw. So this is the shape of my function. I have my function having this shape. Another full rotation again. The x values are from 0 to 180. This is 0 degrees. And the maximum value is 180 degrees. This is the x, and I have, this is the y value. After sketching, let's solve for part B. State the equation of the principal axis of the curve. So simply the equation of the principal axis y is equal to d, and it is 0. So the principal equation of the principal axis is y is equal to 0. Part C. Find the period of the function. Simply the period we said is equal to 360 over b. In this case, our b is 4. 360 divided by 4. And the period would be, I go to menu, to run matrix, 360 divided by 4. And this will give me 90 degrees. So the period is 90 degrees. And for part D of the question, we need to find the amplitude of the curve. Simply the amplitude is equal to A, so the amplitude is equal to 20. And by this, I could solve this example by sketching my sinusoidal function using my graphical display calculator and the rules we learned to find the principal axis, the period of the function, and the amplitude of the curve.